Alright kiddos, welcome back. We've learned how to balance equations. Now we're going to jump into reaction types. And you will see in this class there are 5 types of reactions that we're going to have to learn. Synthesis, decomposition, single replacement, double replacement, and combustion. So we're going to tackle these one at a time. We're going to start with synthesis. So in synthesis, it's a chemical reaction in which 2 or more substances react to produce a single product. So if I have substance X and Y, and I turn that into compound XY, we would call that a synthesis reaction. Now, these don't necessarily have to be elements, they could be compounds as well. So 2 compounds could combine to form 1 compound. Or an element in a compound can combine to form 1 compound. So if you think about the word synthesis, it's building up or creating something. And so we are, that's exactly what we're doing. We're starting with 2 or more things and making 1 thing. So let's just go through some examples. Let's say that I have sodium and chlorine gas reacting. What will the product be if this is a synthesis reaction? Well, some kids say, oh, this is easy, Hummer. Na plus Cl2 makes NaCl2. No, it does not. Remember how to write formulas. Sodium is a positive 1 ion. Chloride is a negative 1 ion. So we don't make NaCl2, we make NaCl, sodium chloride. Now I know it's not balanced, but we can put a 2 here and a 2 there to balance that reaction. That's not so bad, is it? Alright, why don't you try the next one on your own? Calcium and oxygen gas. Write down what you think the product is and balance the equation, and then come back to the video and see how you did. Alright, welcome back. Let's see, Ca plus O2. I hope you did not write CaO2. That's not the product. Remember how to write formulas, kiddos. Calcium is a 2 positive ion. Oxygen is a 2 negative ion. So we make CaO, calcium oxide. And if I put a 2 here and a 2 there, that equation balances also. Now, here's an example of a couple compounds combining to form another compound. In fact, you'll notice that SO2 is something we call a nonmetal oxide. That should make sense because we have the nonmetal sulfur bonded to oxygen. So it falls under a group of compounds called nonmetal oxides. You see, carbon dioxide, carbon monoxide would also be considered a nonmetal oxide. Now these nonmetal oxides, when you dissolve them in water, form oxyacids or ternary acids. So in this case, sulfur dioxide reacts with water to form H2SO3, sulfurous acid. Check to see if that's balanced. Let's see, 2 H's on both sides, 1 S, and a total of 3. Yep, that is balanced. So nonmetal oxides react with water to form oxyacids. Well, the next one is a metal oxide, right? It's sodium oxide. Sodium's a metal, and oxygen, of course, comes up. That's the oxide part of it. When those dissolve in water, they form metal hydroxides. So sodium oxide would be an example. Calcium oxide, barium oxide. Those are all metal oxides. And when they're placed in water, they form metal hydroxides. Now let's see if this is balanced. 2 sodiums on this side, so if I put a 2 there, that gives me 2 sodiums. And I have 2 oxygens, 1, 2 on that side, and I also have 2 hydrogens right there. Yeah, so that balances by putting this 2 in front of NaOH. Alright, try the next one on your own. Now this time the reaction is in words, and you'll have to write the equation for it. Alright, how did you do? Aluminum and sulfur form aluminum sulfide. See, aluminum is Al, sulfur is S. Aluminum sulfide, let's see, aluminum is 3 plus, sulfur is 2 negative, so that would be Al2S3. And that works, Al2S3. To balance that, we'll put a 2 in front of aluminum and a 3 in front of the sulfur on the reactant side. And now try the next one. That's a nonmetal oxide. reacting with water to form an oxyacid. Try it and then come back to the video and see how you did. Alright, water, H2O, and dinitrogen pentaoxide. That'd be N2O5. Remember, nonmetals to nonmetals, we use prefixes in the naming system. And this forms nitric acid. Now nitric comes from nitrates. So nitrate is NO3 negative. Look at your polyatomic chart to verify that. And remember, in these acids, hydrogen acts as a metal with a 1+ charge. So we end up making HNO3. Let's see if we can balance that guy. See if I put a 2 in front of HNO3, that gives me 2 H's, 2 N's, and 6 oxygens, right? And on this side I have 2 H's, 2 N's, and 5 + 1, 6 oxygens. That works. Okay, those are called synthesis reactions, and they all fit this general formula: X + Y makes XY. Now, the opposite of synthesis is called decomposition. So decomposition reactions are the opposite of synthesis reactions. A decomposition reaction is one in which a single compound breaks down into either 2 or more elements or new compounds. In generic terms, the decomposition reaction can be represented as follows: XY reacting to form X and Y. And remember, X and Y can be elements, or they could be compounds, or a mixture of elements and compounds. The thing is, we start with 1 and we break it down into 2 or more substances. So let's do a couple of examples here. NaN3, sodium nitride, reacts to form sodium and nitrogen gas. Do you see how that's a decomposition reaction? We're starting with 1 compound and breaking it down, in this case, into 2 elements. And yes, I know that that's not balanced, but we can fix that pretty quickly. If I put a 3 here, that gives me 6 nitrogens on the right. If I put a 2 here, oops, let me erase this, it's getting a little bit messy there, so let's try that again. If I put a 3 there, it gives me 6 nitrogens on both sides, and a 2 here gives me 6 nitrogens, and if I put a 2 there, it gives me 2 sodiums, and now that equation balances. Okay, the next example, ammonium nitrate forms dinitrogen oxide and water. Once again, hopefully you recognize that as a decomposition reaction. We start with 1 thing, and in this time we make 2 different compounds. Let's see how well that balances. We have 2 nitrogens on this side, and 2 nitrogens on this side, 4 hydrogens. So let's put a 2 in front of H2O. That'll give us 4 hydrogens. And now let's see, we have 3 oxygens, and we have 1 plus 2 more is 3. Yep, that balances by putting a 2 in front of water. Let's do a couple more, kiddos. So why don't you try the next one? It's a word equation. Try the next one by pausing the video, and then come back to the video in a minute and see how you do. Alright, welcome back. So this one says aluminum oxide decomposes into its elements when electricity is passed through it. So aluminum oxide, let's see. Aluminum, as you recall, is Al3+. Oxide is O2 negative. So aluminum oxide is Al2O3. Now it says it decomposes into its elements. So that would mean we make aluminum and oxygen gas. Don't forget, oxygen is a Brinkelhoff element, so it should be written as O2. Let's balance that by putting a 2 in front of Al2O3, a 4 in front of aluminum, and a 3 in front of O2. So we have 4 aluminums on both sides and 6 oxygens. Okay, try the next one. Nickel 2 hydroxide decomposes to form nickel 2 oxide and water. So pause the video, try it, come back and see how you did. Alright, welcome back. Nickel 2 hydroxide. So let's do this off to the side. Nickel 2, isn't that nickel with a 2+ charge? And hydroxide, if you look on your polyatomic chart, is OH -1. So we have Ni parentheses OH2. It decomposes, so let's draw our arrow, to produce nickel 2 oxide. So that would be nickel with a 2+ charge, and oxygen has a 2- charge. So that would be NiO. And it makes water, which of course is H2O. And so there you have it. Let's see if this balances, kiddos. We've got 1 nickel on both sides. We've got 2 oxygens and 2 hydrogens. And I've got an oxygen here and here, and 2 hydrogens there. So yeah, that's balanced as it's written. Okay, so the first 2 reaction types, folks, are synthesis and decomposition. That's enough for this video. We'll continue with a couple of other reaction types in the next video. See you soon. Bye-bye.